All right. Yeah, so today is going to be all about so welcome to Meetup 6 of Data 608. And the topic of this week is going to be storytelling and uh narrative structures, and in particular like how you can take like traditional storytelling structures and adapt them to visualizations. Um just gonna put this. So I'm going to start by just talking about what we're going to be doing throughout the week. Um, yeah, so basically, like, I feel like everyone kind of has been told, like, oh, you got to like make your data analysis tell a good story. Or, I mean, the theme of this class, like, the name of the class is like, I think, visual storytelling. But the goal of this week is to get you to think like more concretely or more or think about stories and their structure in a more concrete fashion. And the two reading assignments are both like focused on storytelling specifically. So we're going to read chapter 29 of Fundamentals of Data Visualization and chapter 7 of Storytelling with Data. And both of those chapters will talk about like how to structure different ways of structuring story and how to apply that to your figures. Um, there's Data Story 3 is going to be due Sunday at midnight. Um, so keep working on that. And the discussion post this week, I just want you to take uh the story that you did for yourself, your like kind of story introduction to yourself that you did in week 1, and I want you to put it in like story arc format. Um, and I kind of give an example of that in where I describe the discussion post. And so you can like if you already feel it matches like a story arc um pretty well, you can just, take the different elements of the story arc and like paste the text, right next to it. If not, you can retell your story a little bit. You can pick one of the different story formats that we talk about, and you can retell your story in that format and show me how it works. Anyways, I don't want it to be a hard assignment. I just want you to um, go through the process with a story. Um, so I'm not looking for a novel. Like, don't overthink it. Just uh, yeah, just pick one and run with it. Okay, so what is a story? So fundamentals of data visualization defines a story like this. A story is a set of observations, facts, or events, true or invented, that are presented in a specific order such that they create an emotional reaction in the audience. And the emotional reaction part is really key to what makes a story different than other forms of presenting information. And I think we talked about this a little bit in the very first week, but this involvement of emotion is actually really important. And I think that the culture in quantitative fields is sometimes like really dismissive of things like stories, dismissive of emotion. Is sort of like we don't want that squishy stuff, um, like anywhere near you know our presentation of our data. Like I feel like that's an attitude that I've seen actually in areas in which I've worked, maybe even something that I've believed myself. But I think like now that this is a bad mistake. um and I've in my life seen like hundreds of different presentations, like quantitative presentations by people, and it's really the ones that like connect on some kind of emotional level that I remember well, like where I actually remember what they told me. So I think it's a bad mistake to be dismissive of like trying to like trigger some emotional reaction in the people you're giving a presentation to, the people that are reading your figures. And this is backed up by research which says that triggering an emotional response is like pretty much the key way that humans communicate with each other. And I think that you can tell stories with your data while still being like very objective in how you present the truth. I don't think there's any contradiction between um between being being like very serious and very objective, and then like also involving this kind of squishier emotional stuff. So, but it is something you have to do to think about intentionally. Okay, so how does a story create an emotional response? Basically, there's like two key parts of a story that are needed, that are generally like present and generally needed to create the emotional response we're looking for. There's usually like some kind of initial buildup of tension, or a buildup, or like creation of some kind of conflict, and then there's the release of that tension at the conclusion of the story. So there's this like arc um where the story builds up tension, builds up conflict, it reaches a breaking point, and then it resolves somehow through the action of the story. And so, like, what's an example of this? So here's a figure, um, and this is a figure which shows the counties in the United States which have the lowest death rates for kidney cancer, in a particular decade, 1980 to 1989. And what I want you to notice about these counties is that the lowest kidney cancer death rate counties, they're all rural counties. Um, so we can like look at this figure, and I don't think it's a stretch to go from this figure to the conclusion that there's something special about rural counties that prevents cancer, that or at least that prevents kidney cancer. And so what might that be? I don't know. We can come up with some hypotheses for what it could be. It could be that like rural counties have lower air pollution, have lower pollution in general. I you know, having been to Los Angeles and seen like seeing the smog in New York, I could definitely believe that. I could definitely believe that like rural counties have lower pollution. Um, Also, like we know that like you live in a rural county, you're super close to farms and uh, super far from bodegas that have, I don't know, that sell chips. So maybe people who live in rural counties have access to healthier, fresher foods. Um, that could be an explanation for why there's lower cancer rates. Or, everyone talks about how stressful it is to live in a city. Maybe people who live in rural counties have a lower stress, like more active lifestyle than people who live in urban counties or suburban counties. I think all of these could be, potential explanations for why we see um, such low cancer rates in rural counties. Um, so, what should we do? Should we fund a big study to investigate um, the reasons why rural counties have such low kidney cancer death rates? Um, well, actually, there's a plot twist. So here's a plot of the counties with the highest kidney cancer death rates. And if you look at them, they're also all rural counties, um, predominantly rural counties. So how can this be? Um, we just gave like a host of reasons why we think um, rural counties might have low kidney cancer death rates, but those like can't really apply if the highest kidney cancer death rate counties are also rural. Something else is going on here. There's something unusual in this problem that we need to resolve. So let's think about a rural county. So let's do a thought experiment. So I'm going to imagine a rural county that has 100 people, and well, there are some counties in the US that have, I think there's one county that has less than 100 people, but there's some very tiny counties in the US. So let's imagine a hypothetical county with 100 people. And let's suppose that in the last decade, one person in that county died of kidney cancer. So if that happened in this hypothetical county, this one person died of kidney cancer, that would actually make the kidney cancer death rate in that county the highest in the entire country. On the other hand, um, let's suppose no one died of kidney cancer in that county in that decade. Then its death rate would be 0, which would actually give it the lowest kidney cancer death rate um, in the entire county. So it seems like, this like one like random bit of chance when it happens in a small county can take the county from having the lowest death rate to the highest death rate. And we can actually bring in statistics to think about that explicitly. So we could say that each person has a probability p dying from kidney cancer. We could imagine that this depended on what county, but let's just pretend that it's equal across the entire United States for a moment. Then we observe um, counties over a decade, and we count how many people died of kidney cancer, and we compute the rate R, and it's just the number of deaths divided by the number of people. And if we asked ourselves like this estimator or this sample distribution R, what's the expected variance for it? Well, for a binomial proportion, we would get p times 1 minus p divided by n. And we can see that like this variance is going to depend on n a lot. When n's really big, like let's say for Manhattan County or Kings County, um, or New York County and Kings County, um, this n is going to be huge, and this variance is going to be 0. And what we observe, the kidney cancer death rate, is probably going to be pretty close to the expected mean value. But on the other hand, when n is really small, um, this variance is going to be very high. And as a result, all other things being equal, we should expect the small counties to dominate the extremes of the distribution. So we should naturally expect for any kind of rare event that the smallest counties will be represented both in the highest rates and in the lowest rates. And it doesn't matter if it's kidney cancer; it could be for anything. Um, and so here's a plot. Um, here's a plot of the age-adjusted kidney cancer rate by county versus the population of those counties, and you can see exactly what I'm talking about. There's like all these counties where there aren't any kidney cancer deaths, and then there's some really small ones where there's been quite a high rate, and then there's this funnel shape where the variance squeezes in as the population gets bigger. And you see this funnel shape all the time in all kinds of different fields. You see it when plotting variables on counties, but you also see it when let's say you're looking at looking at studies with different like population sizes. Um, Studies where they use a really small number of people have a much higher variance in the effect sizes that they predict. And as a result, you similarly see a funnel of the effect size shrinking towards what the true value is. And if there's some bias in, you know, which studies people choose to publish, then actually you may see the effect size shrink to 0. So the lesson of this little data analysis exercise is that you should be skeptical of maps. You should be skeptical of any comparison of groups of different sizes, and you should always incorporate what you know about the variance of your estimates. Okay, so that was a story, um, and it followed a particular type of story arc. So what was the story arc for that story? So I started with an opening, and the opening was a little bit it didn't directly address the problem. It started in a different place. And so my opening was why are kidney cancer rates lowest in rural counties? And then I used that opening to set up tension. Um, and so that's the second phase of the story arc, which is the challenge of this particular story arc. And so not only are cancer rates lowest in rural counties, but they're also higher in rural counties, which seems like a contradiction. And then I had the action phase. We use statistics, binomial variance formula, and we explained why we were seeing this really apparently contradictory pattern. And then finally, we had a resolution phase, which is kind of like the moral of the story. Um, like, what should we do as a result of this story? And that is, we should be aware that this is an issue that arises whenever we are comparing um, some kind of observations over unequally sized groups. So, um, what is a story arc technically? So, a story arc is basically a pattern which a story takes, and there's several different types of story arcs, but they're all kind of trying to achieve the same goal, basically to build up tension, to build up conflict, and then to resolve it. And so what are some other story arcs? So arc one, the one I just talked about, was opening, challenge, action, then resolution. Another story arc, which is I guess common in news, is like lead, development, resolution. And so the lead kind of gives away the main point. So in this type of story arc, you actually start with the punchline. Usually you kind of start at the end. And then you kind of go back and you introduce the problem, you introduce the details, and then finally you have a resolution um, where you return to the main point with all the information. You return to the lead with all the information in the development, and you kind of get to the moral of the story. So if I wanted to do my story arc for this if I wanted to do this lead development resolution story arc for the kidney cancer case, I might do it like this. My lead might be: maps are biased because of population heterogeneities. And then my development might be: you can draw contradictory conclusions from maps. They can show that rural living both prevents and causes kidney cancer. And this is because observations of low population rural counties inherently have high variance. Resolution: this issue plays a role whenever you compare groups of different size. Always consider standard errors. It could do like I could also imagine like an alternative version of Arc 2 where it's like a little bit more aggressive, where my lead was all maps lie to you. And then the same development and resolution uh as previously. And so another type of story arc, which is like a little bit between the first one and the second one, is action, background, development, climax, ending. And so this one gets into the basically gets into the conflict a little faster than the first one. So if I was going to do action, background, development, climax, ending, um, I might start by showing you both figures that showed a contradictory result side by side at once, just to show just and I would say like, um look at this crazy contradiction, like how can we explain it? And then I would go backwards and like introduce the background, um present other examples of this, like what are the challenges they cause and consequences. Then I would like um do the development, like connect with population size. um the climax, like we can explain this using binomial variance formula. We can correct for this using some other techniques from statistics, least squares. And finally, like the ending, like emphasizing again that this is a really important thing, like in a lot of different areas, and you can deal with it. Okay, so those aren't all the story arcs that you'll ever see. There's like you know, there's a variety of other ones. I don't know how many there are, but there's a variety of other ones. They all kind of have the same flavor, though. The important thing, however, is finding a way to translate story arc to your figures. Um, And so basically, when you're doing this, you need to keep like a few things in mind. Probably like each figure needs to kind of have a be chosen very carefully and have a specific place in your story arc. That's not a hard rule, but you should probably be thinking that. And then you're usually going to need multiple figures to tell a story. Maybe if you're like really in a special situation, you can do it with just one figure, but um, probably you need multiple figures. Okay, so here's an example where we're going to do this like purely through figures. So here is, we're going to return to the electricity and carbon intensity of electricity production data. So here's a figure which shows how the U.S. How the contribution of coal to electricity in the U.S. changes over time. As you can see, it it has, so this is the opening. It has like this decline, which gets steeper at around 2010. And so you might ask, like, what happened in 2008 um, to precipitate this really sharp decline in the power share of coal in the US? Well, it turns out that, like, right in that same period of time, something counterintuitive happened. Fracking, like, led to a massive growth in the production of natural gas in the US. And that drove the gas share, or the share of natural gas and electricity very high. And this like almost like one for one displaced coal power. Um, and so you see here, like during this period highlighted by the gray triangle, there was basically a 50% annual growth in shale gas production. Shale gas is just a subset of types of natural gas. This is the natural gas that like fracking produces. And the coal gas transition had a consequence. It actually, even though like I think a lot of times you'll hear fracking being described as a bad thing, it actually did have a good consequence in this case. The power grid in the US got cleaner. So here's a plot of the carbon intensity of electricity production. And you can see it's kind of fluctuating up and down, but then like yeah, in 2010 it starts to decline. And so that's a good thing. Uh, but if you actually look at the axis all the way from zero, you see it's not really a big decline. And we still have like a really pretty far way to go. Um, Eventually, if we were to replace like all the coal production in the US with all the coal power in the US with natural gas, we would basically be stuck at about this line here. Um, and that line is very far from zero, as you might imagine. So we need to do something else. Um, Gas has served its purpose, and another transition is needed. And as you can see, maybe that transition is already beginning. Um, so this is a plot of the share of wind and solar power. And as you can see, it's like kind of low, but it's actually been picking up quite a lot in the last like 10 years. And so it's possible that a new transition is beginning. Okay, so that's like one example of how you could map um you could take a story of what happened to the power system, and then for each basically like you could write out a story, and then for each part of the story you could create a figure or put something in a figure that tried to tell that basically tried to explicate that part of the story. And so basically like yeah, so here um the opening is just, it's like, oh, there's this interesting thing um that's happening. We see coal power is declining, and then we notice like the challenge, like the decline got a bit faster around a certain set of years. And why did that happen? And then the action is we showed like another piece of data. We connected it to something in the news that was like a little bit counterintuitive, and we showed that surprisingly more action uh, that helped reduce the amount of carbon dioxide that we emitted because gas is cleaner than coal. But um, despite that, it's not a happy ending. Um, we still have a long way to go. That's kind of the resolution. Um, and then the ending is yeah, like we need to replicate what happened with fracking, but with a different types of power. Okay, so that's how I think about trying to do story, like trying to map a story arc onto figures. I try to like say like each figure has a very specific purpose in moving the story along, and like once you have the story in mind, it's not like you can like it's often better to get this is why like um your storytelling book advises you to start with a storyboard first. Think about what your story is and then make your figures because yeah, you if you do that, you can sometimes get them to flow a little bit better. So what are some other tips for how to make your let's say you have a really good story in mind and you're trying to create figures that tell that story. How can you do that effectively? So I've taken some examples from fundamentals of data visualization, which I think are really helpful in particular for making figures for busy people. So people that like, let's say they're not your data science colleagues. Let's say instead they're, um, someone in a different part of your organization who's like maybe some kind of executive who's very busy. Um, who's probably pretty smart, but maybe he's not that technical and definitely isn't going to sit in front of a figure for 30 minutes to decipher all the details. And so the idea is that if you want to tell an effective story, you don't want your figure to be too complicated. You want your figure to be as simple as possible, but no simpler than that. So you want to strip away like all unnecessary details. You don't want to be showing too many different things at a given time because if you do, the person will be distracted from the main point that you're trying to make. So as an example, this is basically a figure from Fundamentals of Data Visualization, and it's the New York City flights 13 data set. And here we're showing the mean arrival delay on the y-axis. We have colors that correspond to American, Delta, and other airlines. We have the x-axis is the distance of the flight in miles. The circles stand for how many flights there were uh, that corresponded to that distance. So basically, how many flights between those airports. And yeah, like I don't know, I look at this and I don't really get much of a message at all. Um, I don't know like what story you could tell. I mean, this figure packs a ton of information, but it doesn't tell any kind of story. Um, so this figure is too complex. On the other hand, if you were to look at it like really closely, and if you were to study it, you might start noticing some things. So, in particular, the American line and the Delta line, they're both like a little bit lower than the other line, which suggests that American and Delta have lower delays. And so maybe that's what you want your story to be. And instead you could plot this. Uh this I think like yeah, demonstrates like something like in a really easy to understand way. Like you have, oh look, American and Delta are the most on-time airlines in the data set, and it's yeah, not particularly close. I mean, I guess it's between 0 and 12 minutes, but still like they're the two best. I've colored them in red. And getting this message from this graph would I think be quite difficult. Um so anyway, so that's like one point. You really want to keep your figures you really want to try your hardest for each figure to think of like what is the main message that someone is going to take from this figure, and then like focus the figure on that. On the other hand, it's not always possible to convey the message that you want to convey with a simple figure. There's going to be some times when a complex plot is required. Like you just have a lot of data, you have data that's subtle, um, and you can't like make a simple figure to show it. So in this particular situation, the way you should handle it is you should avoid leading with complexity. So you should lead with like kind of a simple figure to kind of to kind of like prime your audience to understand your complex figure, and then you should show the complex figure. So here's an example. So here's a plot of um, basically the number of different flights of United Airlines from Newark Airport, again from the New York City Flights 13 data set. And we can see in this plot that there's a kind of characteristic pattern. The weekdays pretty much have the same number of flights. Um, Not that many people seem to fly on Saturday, and then Sunday is like a little bit in between. And this is a figure like this might not be your main story, right? This is just like one airline. Like it has an interesting pattern. But this is a very understandable plot. It's very simple and it's very understandable. And this would be a great way to prime your audience to see a plot of this for every single different airline. So if I then, after showing this figure, if I then was to show them this faceted bar chart where you see the number of departures from all the different airlines at all the different airports, um, this won't be overwhelming to them. Whereas if you just were to show this, like if you were just to show this in a presentation right away, there's a chance people's eyes would glaze over and they wouldn't notice like what you wanted them to notice. And so it's not the same to show basically like starting simple like will pay dividends later if you're trying to show complex plots. Let me think. So let me see. So that's actually all I have for today. So today is a short lecture, which I was not expecting. So maybe I will. So I could have fit uh the color bar stuff that I didn't think I would have time for. So I'm gonna stop the screen share and ask if there's any questions.
Question. So in the last one or two slides that you just showed was showing a simple figure before a complex figure. How do you know which simple figure to choose?
Um, so I guess like there's not gonna be there's not gonna be like a hard and fast rule for every case. Um, so in the case of the like I think you have to experiment, and I think this is where showing figures to your colleagues really helps. So I think if you're making figures and you have a really complicated figure and you want it to say a lot of different things, you should show it to some other person and get their take on it and see what about it is confusing to them. Um, in the case of like a faceted scatter plot, like where I mean maybe I'll bring it back up. Right. So if I can. So in this case, where like yeah, we have a bunch of facets, and then on each facet there's like there's a certain pattern, and it's going to be repeated, and then like each individual airline is going to have a different pattern. It makes sense to show like a single facet so people can like familiarize themselves with a pattern. So in this case it's like very natural. Alternatively, like you could have showed the average um or you could have just like collapsed the entire data set and just showed I think it would have been okay to show like instead of just United to show like a time series where you added up all the airlines. I think for this that would have been functionally equivalent. Um right, if that's what you wanted to convey. Um or but for yeah, for a different figure, um yeah, so I think like when you have when you're showing like a lot of groups, showing an example of a single one and working working through like all the details there and then showing all of them, I think that is a natural way to do this, but it just depends. So I would say like if you're going to show a complex figure, you should think about like whether there's like a simple introductory figure that you could use to prime the person um in order to in order so that they understand it more easily. And this I think is very audience dependent. So like I would say this is much more important for a general audience. Like if you were presenting like to an audience of experts, you might not need to prime them because they've already seen figures like this a lot of times. Um, does that? I'm not sure if that's like too vague or if that answers
Yeah,
your
it
question.
helps some. I feel like there's a random component to it.
Yeah, this is inherently subjective. Unfortunately, like visual yeah, making good visualizations, there's rules, but there it's not but there's like there's always going to be an inherent subjectivity. um there's always going to be an
Okay.
inherent subjectivity, which is actually partially why it's challenging, um a challenging thing to do.
Okay. All right. Thank you.
Does anyone else have a question? I know someone wanted Mubashir, you wanted to meet with me before. Would you still want
Yeah,
to meet with me after?
yes, please. Thank you so much.
No,
If
no
you,
problem.
yeah,
um
when you end the class, I'll join. I'll stay.
Yeah. Okay. Cool. Cool. So if there's no other questions, then I guess I'll end the meetup. Okay. Thanks all.
All right. Thank you.
Have a good night.
Thank you. Have a good day.